Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and today we're going to be taking a look at actually building an Syslog server, or specifically for logging. So anytime you have a machine, especially ones that are going to run headless, you need a way to be able to monitor what their current status is, and you don't necessarily want to have to log in all the time to be able to check that and just have them reported on their own to one central location. A Syslog server is a great way to do that. So we're going to be creating the server and then also creating the client configurations for them to be able to submit their logs to that centralized server. And just because we also want to cover best practices as well, we're going to add a layer of encryption on top of it in order to be able to make sure that nobody's snooping in on whatever services we have running on our clients. So let's go ahead and get into it. So what I have here is pretty much a base install of our usual Alpine Linux. And I have two machines here. I have the Raspberry Pi 4 and the Raspberry Pi 400 arbitrarily chosen. This actually works with all versions of Pi, and also all versions of Linux are capable of supporting Syslog. And Syslog is actually a very consistent tool. If you're used to actually looking at logging, things like that through the command line, you know that Syslog is usually your first go-to. It's going to carry all of your system messages, things like that. So for Alpine Linux, since there's no actual persistent storage unless we explicitly define and create it, obviously all of those logs are going to be lost. So by centralizing them onto a non-volatile storage medium, like an external drive, for example, we can actually create some pretty good logging capability that will persist long term to allow us to be able to troubleshoot things like system crashes. So let's go ahead and get configuring on our first Pi here. This is going to be our actual server itself. So let's just set it up. So I'm just going to log in as root. I notice it says that it's got the power indication in the top right hand corner indicating low power, but to be honest with you, it's using the official power supply, so I'm not entirely sure why it's doing that at this moment, but this is actually a pretty low power operation, so it shouldn't impact it overall. If it cuts out suddenly, I'll figure out something, but maybe switch to a Pi 3. So let's go ahead and get this set up. So first we're going to do setup Alpine as usual. Keyboard. We're going to call this Syslog server. We're going to set up Ethernet 0 for DHCP. Usually if you're going to set this up as a server, you actually do want to define a static IP address. Because I'm just doing this for demo purposes, I'm just going to keep it as the default for DHCP, because my router actually assigns it and sticks with particular MAC addresses, pretty much gives them the equivalent of a static IP. But if this was a larger network, or if you didn't have that kind of reservation system, it's certainly something where you'd want to set a static IP, or at least reserve one, so that way it would stay consistent. Otherwise, obviously, your clients wouldn't be able to submit to it. So, and we'll hit done because we don't want any wireless LAN and no manual configuration. So now it's going to get an IP address. And it's 192.168.15.138. And what I'm going to do is just notate that here. I'm going to use the right keyboard and notate it here. Excellent. We're just going to set a super secure password. It's not going to work because I typed on the wrong keyboard. There we go. Okay, now it's asking for our time zone. I'm just going to set standard US Eastern for my location. No proxy server. NTP client, again, is going to be Crony. And NTP is actually going to be very important for this as well, because realistically, it's going to timestamp everything based on the time that it thinks it is. So we want to make sure it's as accurate as possible. We're going to use first mirror. We're not going to set up a separate user for this. We're just going to use root for this example. You could set up a separate user, but realistically, you're always going to want it to be root. SSH we're going to set up as well, because we're going to do the majority of our configuration using that. So I'm going to set it so I can log in as root. We're not going to set a key, but it is going to generate one. And when we actually get into the TLS configuration and everything else like that, we are going to be using OpenSSL to actually generate that, which is shared pretty much with anything else that uses SSL, like SSH. We're not going to set this up on a disk. We're going to use the default for configs and for cache, and we should be good. Do lbu commit-d. We should not have to actually install or enable community repositories, but we can anyway, just for the exercise. So vi/etc apk repositories, just to keep everything consistent in our life when we're setting this up. We'll check it. 13,000, the two packages added since the last stream. And we commit that. So let's go ahead and pretty much get our server set up. So first thing we're going to do is apk add r syslog to install the actual syslog service. And it's very lightweight. I mean, it takes up almost no space, but that's what's actually going to be doing the receiving of the messages. And also it's going to be the same package that we use on the client side. So now that that's installed, we need to configure it. So we're going to do vi/etc rsyslog.com. And we see there's a number of things in here, but the real important thing is that we need to enable it to be able to communicate. So we need to add a module. So let's go down here. And we see it actually has examples down here as well. So I'm just going to add to the end, just because it's going to make life easier. So we're going to do module load equals imudp. And what that's going to do is it's going to submit a UDP packet for the particular syslog messages that we want to transmit. So it's not TCP, it is UDP. It's just going to send it at the server. But that way, if the server goes down for some reason, for example, or if the client goes down, you know, there's not going to be any kind of synchronous communication that's going to cause the other system to hang. So UDP is definitely the preferred option for this. And then we'll also add a second line, which is input, just so it knows that it's coming in this direction. Type equals imudp. That should be in quotes. And then port equals 514. And 514 is the standard port allocated for syslogging. So it's below 1024, so it is reserved, but it is the default port. But you could set that to whatever you wanted if there was a conflict for whatever reason. And that's it. So we'll just add a new line to the bottom to keep everything clean. We will write that out. Then we'll do rc service, rsyslog, start. Started successfully. So let's add it to start on boot. So we'll do rc update, add rsyslog default. Perfect. So now it's added to start on boot. The service is running, so it's ready to receive messages. So let's actually test that. So we can do logger, and logger is a default application inside of Alpine Linux. -n for network address. And in this case, we're just going to do 127.0.0.1. And we're going to do -P 514 for the port, -T and then dash lowercase d, followed by our actual message in quotes. So we'll do test message. And we send that, and I might have transcribed something incorrectly. Okay, so it's util Linux is pretty much the package that we're probably going to have to install. So let's do apk add util Linux. And that works. Okay, so that replaces the actual logger package. So it is there by default, but it's not giving us the network option. So I'm going to update that. And likely what I'm going to do is I'm going to post these entire instructions to GitHub with some snippets of code, just so that way it's easier to follow along instead of having to transcribe it from the video. I think it's going to be a lot easier that way moving forward, and I'm probably going to try and do that on previous videos as well, just to make a more comprehensive and searchable reference for this type of thing. So I'm just going to add that to my notes really quick. So on other versions of Linux, it will actually go under Syslog. So when you don't have anything by default, it will go under the system's syslog, which is in var log syslog, and no extension on the file. But for Alpine Linux, it goes under messages. So see, and if I actually tab twice, we can see messages is there. So we do see our message, our test message was successfully transmitted to itself. So we see the 127.0.0.1 test message, and that's pretty much how all of our client messages are going to show up. So if we go from there, we can say that everything is working on the side of the server. So we can commit this to LBU. So let's go ahead and work on our client. So our client is going to be the Raspberry Pi 400 in this particular case. So I'll just switch this over, switch keyboards here. If I can find a place to put everything. There we go. So same thing here. We're just going to log into it and set it up. So this is, again, a vanilla version of the OS. So root, set up Alpine, US. We're going to call this Syslog client, Ethernet DHCP. In this particular case, we don't actually care what the IP address is, since it will just be submitting it to the server. We only need to know the server address, really, but we will keep track of it here just so we can SSH into it when we do the TLS example. And no manual config. Setting up Ethernet just once again. Same exact way we did the server in this particular case. But this does work over Wi-Fi as well. We do see our address that was assigned was 192.168.15.137. I will notate that here. Perfect. We're going to set a password that's very secure. Set our time zone. No proxy server. Crony is going to be our client once again. We will set our mirror again to the default. We're not going to set up a user once again for this, but again, it wouldn't matter if it was. This is going to be set system-wide. We'll use OpenSSH. We will permit root login just so for our purposes today. And then no disk, store configs to the memory card, store cache to the memory card. And then we will do the same thing just with enabling our repository just for consistency. Because it's easy enough. All right, and that concludes the initial OS config. So now let's set up the client. So we're going to do the same thing that we did before. We're going to do it all in one shot, though, instead of having to troubleshoot. So we're going to do apk add our syslog and util Linux. Just so that way we have the network support by default. Now we're going to VI into our configuration. We're going to go to the bottom. Because we still want it to log locally, so we want everything that exists here. We just want to make sure that we're going to duplicate the logs and send it to a separate server. So we're going to do star. So pretty much anything that comes in at any severity level, although we could define that here. We're just going to do everything. Actually, I'm just going to give this a little bit of space. It's a little easier to see. So star. Then we're going to do @ and then we're going to do the IP address for our syslog server. So that's 192.168.15.138 colon 514, which is the port. And pretty much that is it. So we should save that out. We're going to restart that service. Whoop. So we restarted it successfully. We didn't get any errors on the configuration. And now we can make sure it's set up to run by default. So we'll do rc update add our syslog default. And then we can test it. So again, we do logger, and we just put our message, because we set it so all messages will go there. So we'll just say, this is a test message from the client. Okay, we didn't get any errors. We're going to tail our local log first, and we're going to do tail var log messages. And we do see that it did in fact show up here from root. This is a test message from the client, so it's still working locally. But now if we switch over back to our server, which hopefully didn't decide to go crazy. Otherwise, I'm going to switch over to... No. I actually had some issues with this earlier with switching back and forth for some reason. So this is why we're going to use putty for a lot of it also. But I'm just going to get the session going here so we can have both up. Unless it's shut off entirely. So remember when I said that there was that thing where... Remember I said there was that thing where it's showing the lightning bolt for some reason? It did shut off. And I'm not entirely sure how it was receiving power. I just want to point that out. Actually, I think it was backfeeding from the HDMI. So now the lightning bolt's gone because it's actually powered up, but I think that's why I was having issues earlier. The switch on the power supply, because this is one of those kits, isn't labeled for which side is on and off, so I assumed power on meant that it was actually working. We'll give it a second here just to synchronize, and then we'll log in again. All right, so now we're back. So we're probably gonna have to resend our actual message. Yeah. Okay. So let's just go ahead and tail this log. So -f/var log messages. All right, so it accepted the password. I did just log in through SSH, so we do see that reflected here as well. So now if we switch back to our Pi 400, our client, and we rerun the same one, and I'll just add a 123 at the end, just so that way we can make sure. We run it here, we go back in and tail our local messages, we do see that message reflected here. When we switch over to our server, we also see it here. So you notice there's a bit of a thing where it's not showing which machine it's from. And we're going to get into that in a little bit, but we can actually configure it so that way it will specify a specific syslog file for each individual machine, and that will allow it to be able to differentiate a lot easier. But for a base config, it is submitting to the same place. So if you did, for example, want to submit from your scripts, you can use the logger command to be able to do that, and you would just preface it with something. So we could put client in the actual message itself, because you can run this from any shell script or anything else like that. There's also facilities to do it for most programming languages as well. So you can actually put whatever information you want to identify this particular client if you were going to generate messages from your own processes. So, for example, crash scripts, things like that. But obviously, we do want to make sure that it's actually going to be able to identify who it's coming from, because if you have 100 of these, it makes it very difficult to know which one is having the issue. You don't want to have to log into all of them. So, but we can run that. We come back over here, and we would see that it is showing up as client. But it does show the host name, the syslog client here as well, actually. So it did say that. I named it syslog, so I overlooked that. So, but I do want to note that the time looks like it's different between the two machines. So we are getting different timestamps. So the actual timestamp that we're seeing here for the client is from... Actually, I'm not sure if it's the local time or if it's when it was actually submitted. I would have to check that. But pretty much... Pull up the right keyboard. I'm just going to check the date really quick. And let's see if it's correct. And it does not look like it's correct. So we do have differences between the two dates. I'm just going to correct that really quick, just so we don't have that. And that's just crony, that's just related to my network config. And usually you see me do this when I actually set it up. Excellent. So now that's showing the current date correctly. All right. So now future messages should come through and reflect appropriately. So, and we do see that it actually selected the source. It didn't have the correct time at the time, or did it? Looks like it did. So 12.4.139. So perfect. So let's go ahead and we're going to actually log in through PuTTY right now. And let's set up our TLS configuration. So I'll leave this up on the screen just so we can watch it as it chugs along, just because it won't impact us. Let me make sure, there it is. Make this a little bit bigger. All right, so now we're at the server. So to start the TLS configuration, which is going to add the SSL, first thing we need to do is, let me type on the right keyboard, is we need to add our OpenSSL package, which realistically should be installed already, but we're going to make sure. So we're going to do apk add OpenSSL. It's already installed. Perfect. So next we're going to generate a CA key. And CA stands for Certificate Authority. And what it is it's pretty much going to be the thing that authenticates the keys that we generate for our server and all clients in order to validate that somebody's not just, pretty much getting in the middle. So it's going to be a key that we do not share that we're going to use to sign and validate the actual keys that we generate for each machine. So this particular key that we're going to generate is going to live just on this server. And we will actually submit signing requests, certificate signing requests, in order to sign it on the server before handing it back. So it doesn't leave this server, just for security reasons. So we generate that with OpenSSL genrsa-out ca.key, which is the name of our file, 4096. And because we never want to delete that, we're going to just add it to LBU in this particular case, just in case the system shuts off unexpectedly again. Otherwise, we have to do the whole key, rekey all of the machines. So in this case, I'm in the root directory, so ca.key. And generally speaking, in production, you wouldn't necessarily want to save this as a part of your startup config. You would want to have this on more secure storage that would not be, readable or otherwise accessible by anybody who could copy that config. So just something to keep in mind. But for the purposes of this, in case it shuts down unexpectedly, I don't want to have to restart all of this. But now from that key, we actually want to generate our certificate. So this is our CA certificate. And this is actually going to be copied to all of our client machines in order for them to be able to validate the key, the certificate chain. So the chain of authenticity. So I'll just copy that in, but OpenSSL REQ-X509, which means it's a self-signed certificate, -new, -nodes, -key, then it's our key address. We're going to make it SHA-256 encryption, and it'll be valid for 1 year. And the out file is going to be ca.pem, and that ca.pem file is what we will actually copy over. So hit enter. It's going to ask us some information about it. So we're going to put our country name. Right, we don't actually have to fill out some of this. Right, and we're just going to call it Syslog. Again, this doesn't register outside of your network, so it doesn't actually matter what it is. Organization, doesn't matter. Fully qualified domain name, again, doesn't really matter. It says or your name, so let's just call it Syslog once again. Email, again, is not required. So now if we ls our current directory, we do see the ci.pem file now exists. And again, we're going to add that to LBU. And this is something that we will definitely want to add to LBU, just because we're going to need it in the future. But we're also going to copy it to a second location, which will automatically get added to LBU the next time we save. Perfect. So now let's move on to creating our server private key. And this is pretty much exactly the same way that we generated our CA private key. And it's the same command, just with a different file name. All right, so we did that. And now we want to use it to generate and sign a certificate signing request that the server will use in order to generate our certificate. So it's OpenSSL REQ for request -new -key, and we define our server key -out server.csr. So it's just going to create that request. It's going to ask us the same information. This time I'm just going to call it Syslog. Actually, we'll call it Syslog here. And then for our common name, we'll call it Syslog server. We're not going to put any password or any additional information. And when we ls, we do see that our CSR was created successfully. So now we want to sign that CSR. Since we are on the server already, we don't have to transfer it for this, but we will for the client. But we want to sign that certificate in order to, or sign that certificate signing request in order to get our certificate. So this one's a little bit longer than a line, so I'm just going to read it out really quick, but it's OpenSSL X509 -REQ -in, and then our certificate signing request -CA, ca.pem, right? So the PEM file that we created, then ca.key, which is our private key that stays secret to this server, and that's ca.key, then -ca create serial, which means we want to sign it. -out is server.crt, which is going to be our certificate that it's going to output. And then the number of days it's going to be valid is 365 with SHA 256 encryption, hashing algorithm. Right, so we actually hit this. It tells us the stats that it used in order to create it. And when we ls our directory again, we see our server.crt is now present. So the CSR, the certificate signing request that we created, actually is meaningless now. We can delete it if we so choose. So, and we're not going to save the server or key or certificate in this particular location, but we are going to go ahead and copy these files over to a directory that our syslog can access. So first thing we're going to do is let's make sure the directory that we're going to copy it into exists. So we'll do make dir -p /etc r syslog.d and then certs. And the reason we do the -p is because we need to create the rsyslog.d and the /certs directories. And we're going to do that with one command. So that's what the -p means, is parent. So now that we've created that, we can copy in our certificates. So we'll do ca.pem. We'll do /etc r syslog.d certs. And then we'll cp our server certificate. CRT. And then /etc r syslog.d certs once again. And then the final file that we actually need is our key. Perfect. So now we've added that, and because it's in the etc directory, it will actually automatically be added to LBU. So if we do LBU diff, we do see that the keys are actually added right here. So we'll do LBU commit -d. Again, these keys don't actually matter. I'm going to be deleting them after this, so it doesn't matter that it just showed them. But point being is that they're present. Now we just need to make an update to our syslog configuration. So we're going to do vi /etc rsyslog.conf. We'll go down to the very bottom. And we're going to change this right here. So the two lines that we added, we'll just go ahead and delete those. And I'm going to copy it in. I am going to have to do some cleanup just because I have tabbing for my notes. There we go. All right, so we see that it already has the locations that we for the files that we just copied, the /etc, our syslog certs, ca.pem, server.crt, and server.key. And we have the definitions for those particular variables here, so we can use it as it's actually receiving this traffic. And inside of the actual IMTCP particular request, and it's not UDP anymore, it's TCP. So we technically could have left our UDP there as well, but for TCP, because you can have TCP and UDP both listening on 514, it's just different functions. And then for our permitted peer, here we have client name, but we could also put any, but I believe we're going to check it here, but because we have anonymous listed here, it shouldn't actually care. So there shouldn't be any authentication associated with it. As long as the certificates and everything else like that check out, it should work as expected. So let's save that out. We will restart our service, so we can do rc service rsyslog restart. It says it could not load the listener. Because it doesn't have LMNSD GTLS. And we do have to add the TLS package. So do apk add rsyslog TLS. Interesting. So let's actually go through, see what we can do about this. So error during parsing file of conf on line 97, if we actually go into it, just verify that it is the line that we think it is. Down here is where it actually shows the line number out of the total lines. So 97 is input. So right here we're stream driver GTLS, and then stream driver.auth mode is what it's complaining about. So it doesn't have stream driver. So if we actually look here, stream driver not known. So we could potentially try and actually just to remove that. And just see if it will do it without it. Although it is working for the one above it. Let's just try it. And actually, it looks like a double specification because we do have it listed above it as well. So let's delete this as well and just try our port. And that did work. So it looks like it may not need that at all. Just going to notate this in my notes. Okay. So we'll see in a second if it actually uses it. But now we can just commit that. We will just tail our log really quick. In this particular case, because it's encrypted, we can't actually send it to ourselves, just because we don't have it submitting using the encryption. So we will have to actually configure this on the client in order to get that to go. So we'll do /. Actually, I'm trying to think. Yeah, let's do it. And if you actually look, it shows the errors that we got on the command line when we were trying to restart it inside of this messages file as well. And I may need to make this a little bit bigger, but I don't know that I'm going to be able to do that, so I may need to make the text smaller. But we'll play that by ear. So let's try connecting to our other machine really quick through PuTTY, just so that way we're going to have an easier time copying in everything instead of having to type it manually. And I will need to quickly just get this font changed and then switch over in OBS. All right. There we go. So let's go over here and let's configure our client. So pretty much what we're going to be doing is doing the same kind of thing where we're going back and forth and actually generating our actual client key. We're going to be generating our certificate signing request. We're going to submit that request to the actual server, which has the CA key, and we're going to sign that certificate signing request in order to create our certificate for our client. So let's go ahead and do that. So we start with the same command again that we ran on pretty much for everything else to create our private key. So open SSL. We do know it's installed because we did have it installed previously. It should hopefully run without crashing. There it is. And of course, this takes a long time in order to make it random and secure. So now that we have that, let's go and generate our certificate signing request. So it's OpenSSL, request, new, key, and then the out file is the CSR. It's going to ask us these questions again. So country name, New York, no locality. Our organization will be Syslog, no unit name, and we will call this Syslog client. No email address, and we're not going to put a password. Right, so if we ls the directory, we see our CSR and our key are both present in our directory. So now what we actually want to do is we want to copy over the CSR to the server. So we will do cat client.csr, and we're just going to copy this content here. Okay, and we'll switch back over to our server. All right, I'll exit out of this. And right here, we don't see our client.csr. So we're going to create it. So I'm going to do VI, and I'm going to use VI in particular because it copies multi-line text very well when going across, especially from Windows. So nano can be inconsistent, especially with line endings, things like that. It gets a little weird. So we're just going to do this and then do client.csr. for certificate signing request, hit I for insert, right click, and write that out. And now our CSR is actually transferred over. So now we can actually sign it using our CA key. So still on the server here, we're going to do OpenSSL X509 request. So same way that we signed our server certificate, we're going to do that same thing, but with the client CRT specified here. So we run that. Now when we ls the directory, we do see our client.crt is now present. So now we actually want to copy back 2 files over to our client. So the first thing, we're going to cat our client.crt, and we see that this is our client certificate that has been signed, and it says begin certificate, end certificate. Right, we'll switch back over to our client, because before it said certificate request, right? But we're going to do vi client.crt. Hit insert, and we'll paste it in. We'll write that out, and now we see it exists. So the CRT now exists in addition to the key. But we need to be able to also validate that certificate. So we need to copy over the ca.pem as well. So we'll go back over to the server. And if we ls, we see ca.pem is there, so we can cat ca.pem. And pretty much what PEM is it's a PEM format, but it can have multiple parts of a certificate in a single file. But we're going to copy this particular certificate, go back over to our client, and we will do vi ca.pem. Put it in insert mode and copy in the certificate. Then we will write that out. When we look, we have ca.pem, client.cert, and client.key, which are the 3 critical files that we'll need. So now everything's transferred over. So let's go ahead and copy those files into the certs directory. So first thing that we're going to do, we need to do the same command that we did on the server, which is make dir-p rsyslog etc rsyslog.d certs. Then we need to copy over our ca.pem, then our client.crt, and then our client.key. Perfect. And if we do LBU, because it's in the etc folder, it's automatically going to be added. So let's go ahead and just save it now, since we went through all this work. We want it to persist through reboots. And let's update our config for Syslog, for our Syslog. So rsyslog.conf once again. We go down to the bottom where we had our entry from before, and it's going to be quite a bit longer this time. I'm just going to hash this out just so we can leave it there. Oop. And we're going to paste in this right here, and I'm going to do the same thing. Neaten it up a little bit. Although actually I will need to add these back, I think, for this line. Okay. And yes, I do. All right, and it's saying permitted peer, so it actually does want this to be present. We're going to change this to syslog server. Auth mode is going to be name, so it's not nothing. It does actually require authenticating to the correct server, just because our keys are obviously going to match up to that. And then for our particular files here, I'm just going to copy this. Oops. And we're just going to replace the path 2 with the actual path, which is the certs directory that we just copied it to. Perfect. Right, so we write that out. And now let's go ahead and restart our service. But first, just like we did before, we have to add the rsyslog TLS package. So we'll do apk add rsyslog-tls. Okay, it just installed that. So now we can do /etc/initd rsyslog restart. Oh, we may actually need to install that package. Let's just try it. And that worked. So omr elp. Now when we try it, it says it was unable to open the connection to the remote peer. Oh, because we didn't define the server IP. If you look, it actually says it right here, server IP. My apologies, I forgot to update that. But it didn't error, so we do have the correct packages installed. So let's just correct that address issue. And here where it says target, that's where we actually want to put our server IP address. That's 192.168.15.138 for our example today. Right? And now it started successfully. It was able to establish a connection, and that way it's actually able to log in. So let's add that to LBU. Perfect. So now it's saved. So looking back at our server, let's see if there were any messages saying that we connected. Right, and it says that it actually tried to go through, everything else like that. So we don't know if it's actually working or not. So let's go ahead and actually try and submit something to it using the same test that we did before. So we'll switch back over to our client. We will just do logger once again. And it didn't throw any errors. So let's switch back over to our server. And you're actually seeing it before me. And we see that it did not go through. So it did close the connection. So let's fix the config. And that's related to the input right here. Oh, actually, we also have the permitted peer. Let's correct this. Let's just try that first. All right, we do see that it started. Let's go back over to our client. Try the same thing again. Right, no errors. Switch back over to our server. And actually, I'm not sure it went through. Let's just restart this once more, see if we get an error. Okay, so it did say that there was no permitted name found. Let's just see. And it showed it with capital letters. So we actually need to match what we put in as the name on our certificate. So that is likely why it's not going through. So in our case, we authenticated, but on the server side, we need to correct that as well. And there we go. Okay, so let me go back to the server and show you what this actually says. But it says pure name not authorized. So we just need to correct that. And the name that's showing up is caps syslog client, but we do see the connection is there. So let's Control C out of that. Go back into our configuration. Type it in verbatim. Right, it is restarting. Right, and there we see that it has started. Let's go back over here. We're just gonna do the same thing on the client that we did a second ago and just restart the software just so we see that the login was successful. Right, and we see it worked over here. We go back over on server side. And we don't see the same error that we had before. So we hit start. And we do see this here, and I think that it may be related to the previous one. So let's actually just see if it works. So we'll go back over to 137. And let's just try this. This is attempt 3. And we see that it still didn't come through, so there's still a TLS error. So unexpected TLS error, -110. So let me just verify what that is really quick. So what I'm looking at is I'm just looking at documentation, just seeing exactly what other options are supported or if there's a syntax error on my side. And another option that they're suggesting is OpenSSL instead of using the TLS driver directly. So let me just see something here. Is there a difference between the way that it's implemented? They don't make it easy. So let's just try it. Again, sometimes the documentation on these things is absolutely terrible. So we're just going to try it out, see if it works. Otherwise, we'll try something else. And what that's referring to is instead of using GTLS, we're going to use OSSL. Which means we need to install it. So apk add r syslog-ossl. We're going to do apk search r syslog and see if there's something that we need to add. Or group OSSL. There may not be. So let's just try it. Let's restart, see if it works. So we made that update. LMNSD. It may not exist. Let's see. Right, so we're seeing the actual available packages that we searched. So let's just copy this file and do the same search. It doesn't look like it has it. So let me see if there's a way to get that. Yeah, it does want us to use GTLS. So that is annoying. But we need to stay with the example that we had previously. All right, so this is fine. I'm on the wrong machine. Oh, can you even see that? I'm on the wrong machine. Right here. Okay. So we'll go back in, edit our config. Let's put back the GTLS. Actually, it does specify it as lowercase. I'm not sure it matters, but I'm going to try and match this example and see if it's reliable. And just quickly, for permitted peer right here, if you wanted to put multiple peers, you can actually do a comma and then do additional quotes. So you do actually like this. So brackets, and we can do client 2, for example. So, just a way that you can do it without that extra quotes right there. Check everything else. They did actually add a name here. Let's try that. Okay, so that did work. Let's go back into and tail this. So we do see that it started. Let's switch back over to our client and try submitting the packet again. Okay. We'll switch back over to the server. And we may need to just restart it once. So I'm going to stay on the server really quick, and I'm going to restart it on the client. I don't think there's going to be any change. So we're still getting the unexpected GTLS error, -110, that the TLS connection was not successfully terminated. So let's just try searching that really quick. Let's actually look on our client and see if there's any messages in the syslog that it's not displaying locally. So we are getting additional messages here. So where did we start? So we had 3 up here. Error waiting on required session state, session broken. Then it shows our action may not work as intended. Then here, error opening connection to remote peer object, connection to server. That's going to keep coming up with the same thing. Let's see. Lib-relp error. (10015). And then it says there should be reasons for this, but action 6 OMR ELP. And then it repeats. So let me do a quick search for that and let's see what we get. Let me actually make sure. Did I specify the module correctly? Because we have OMR ELP up here. But technically this should have a second command according to the manual. Although this does the OpenSSL once again, but I'm just going to put GTLS. And I believe we already installed that. Yeah. Let's try that. Am I? Yeah. Okay, so it only has one TLS instance, but it says it wants GNU TLS, OpenSSL, as the parameter. So let's actually put that, because GTLS is technically shorthand for GNU TLS. Let's see if that goes. Well, that's not helpful. So one way we could do this is just by kill all our syslog. Right, we see it's process 4088. So let's just try to kill it manually. And then stop it. And now we should be able to start it again. Alright, and we didn't have any errors that time. Interesting. What's our timestamp on here? This was 3 minutes ago. Oh. 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 Let me switch over. Let's actually do our test first. Right, so test 5. It was almost. I'll show you what I'm looking at, but short form is I'm not seeing the same errors that I was before. So I'm just going to restart this once more. Right, so we're back at start right here. And we'll go back over to the client. Let's restart this once more. All right. Looks like it did error out. So still says error opening connection. That was from 31. Oh, it may not actually be starting. Let's do... Says it started. We see it's now 4453. Are we seeing a 5? I'm not seeing a 5 in here, so I'm not seeing it actually commit any new information to the actual log. Actually, let me do this. So I'm just going to reboot this really quick, just because I have a feeling a connection is stuck open that's blocking the port that's causing it to hang. And you definitely see how annoying the best practices are sometimes. So generally what the idea with the TLS, because it's not required at all, especially on a home network, but if you were on a higher security network or like a corporate LAN, things like that, where you didn't necessarily have control over who could access it, and potentially there's money riding on it, it is something where you would want to make sure that all of your data is encrypted by default. It may not matter depending on what your security requirements are, but for TLS, it is definitely annoying just because you have a lot of different packages that have to work together that are not necessarily supported by the same group. So, for example, our Syslog is maintained, as they call it, by a different group than the OpenSSL and TLS packages that they're including, or at least the things that they're based upon. So it does cause some additional issues. If this was Ubuntu, it would be a bit more supported just because they have a lot more resources to make sure that packages are working correctly. But again, Alpine Linux is not for profit, so, or as far as I know. But it's it's definitely something where there's a lot more in terms of potential variability or contributed packages. So it should be started back up. And let's just check our status really quick. It says it started. Let's just check. Said clock is skewed. Okay. And it looks like it wasn't happy still. And before I restart the other process, let's actually go down here to the bottom. And because we commented this out earlier, which was the handler to send it over unencrypted, let's actually add this command, which should this is technically the legacy code for this. But it adds pretty much the OMRELP at the beginning. I don't know what we need to put for template, so I'm just not going to put anything at this point. And let's just see what it does. So it looks like the connection is successful, but it's not actually making it to the log. And just so you know, this is the actual kind of stuff that I do before every video. is usually try and get through this, but for whatever reason I couldn't do that today. But either way, I don't know that I would have gotten through it, but probably would have just kept it to unencrypted and kept it a short video. But caution to the wind. So we're just gonna push forward. Let's see. Otherwise, it won't work, and I'll probably cut it out. So we'll see how that goes. Oh, pride. So let's see. Yeah, and the problem with this is it doesn't actually have a good example for the legacy method like this. Again, it does say OpenSSL. Did we try that on the client? So that's tls.tslib equals OpenSSL. Let's just try it. The fact that it didn't error is very concerning to me, but that's okay. If that worked, I actually would have been upset. It did not come through. Just gonna make sure. So I do see it initializing, I just do not see it actually sending it when I try and do the test. But I do see it recording here successfully. But so we are seeing action 6, action 7. And in this case, it does say connection server. So let me pull back up the server really quick. Let's take a look at that config. The example adds another definition here, so I'm just going to add it just to see if it actually does anything. So it's I'm just putting back the capital letters that I removed earlier. All right, and we'll put anonymous here. And then it just puts that here. We'll restart, see if we get it. And it's saying the default NetStream driver. Did I spell it right? I just put drive, I didn't put the R. Okay, so it started successfully. Okay, so we'd see it did start. There's no messages yet. Go back over to the client. All right, we do see that it initiated it when I did try and run the test. So, and it is showing the name. So in this case, it has .internal, which is the actual domain that I use for the network that I'm on. But it says syslog client, command syslog. So the connection is being made, but I don't see that the data is actually going through. And if we look back over at the server itself, or at the client itself, we do see that error opening connection to remote peer. Now, something that it did say is, in the example I was just looking at, was it wanted to use a completely different port. And while generally speaking, that is not typically an issue, considering it's the only process running on it, I am just going to change it just for a good measure. Just to make sure that there's no conflicts or anything else like that that would cause an issue. In this case, it says it cannot connect to remote peer, which is fine because we have to configure that as well. So we'll go back over to this server. Control C out of that. Go into our config, go down to the bottom where it says port number. We're going to change that to 6514 as well. And restart. Then we'll go back in here. If this is it, I'm going to be very upset. So we see the connection. I just did logger test again. So the connection came up. But once again, I go back over here. Right, so this is the client. We do see the action 6 OMRELP suspended, blah, blah, blah. And it does say it has a retry coming up. And it says, should be reasons. And it still says error opening connection to remote peer. And actually, it says, because we're not doing authentication using the certificates in order to be able to do it, we may be able to just get rid of the actual definitions of the other certificates. Let's try that. So I'm going to comment all of these out. And let's start here. And actually, I'll just copy this in. Because why not at this point? Let's see. Right, so we have our path to our ca.pem. So we can copy that over. Our target, 192.168.15.138, 6514. And the action on this is OM forward, so it's going to forward all messages. Let's see what it does. Right, no errors. This is what I like to call classic. Right, so I'm going to send another test file. And we see it does make it through. So we see Syslog client recognized here, root 1234. Now we did get an error saying that the key file was not set, etc. Certificate file is not set. So just in terms of actually trying to see this through, let's switch back over to the client. See if we can get it to go, but technically it is going over the encrypted connection only on the second port, because we actually don't have any other listeners for regular ports. But I would definitely like to see this. And actually looking at it, that is the same exact format that we have for the server. So maybe I can just copy that in directly. Right, and instead of server.key, we'll do client. And let's see if we can get rid of those particular warnings. Okay. And we'll say this is a final test. And when we go over to the actual server side of it, we do see it did make it across. And this time we didn't get our warning saying that the certificate and key file was not valid. So it is making a successful connection. I'll send another message really quick so you can see it come in. Right, and we see hello world came through. And it does show that it's Syslog client. So it's differentiating between the two systems. So for example, if we go over here and we just do logger, this is a test from the server, right, which is the local log. We go over here, we do see it differentiates between the two. And also there's a difference in the actual precision. So for example, the actual messages coming in from the client do not have as precise of a timestamp as the local server. And that may be settable, things like that, but it is something where, you know, it's it's not going to be that precise because it's going across the network. So it's going to only be within a certain level of precision anyway. But we do see that it is showing up our Syslog client, Syslog server, so we can differentiate between the machines. We see which user sent it. So if we have multiple users logged into the same machine, or for example, like Apache running under its own user, or any of the other similar types of services, we can kind of get an understanding of which segment of the actual machine is currently throwing that error. So especially if you're running every process under a different user, it makes it very easy to be able to differentiate where the errors are originating, just both generally as well as when you aggregate syslog like this. So I think I've had my fill for tonight. So no, actually I had a lot of fun. So definitely thank you if you tuned in, if you made it all the way to the end of the video here. I definitely appreciate you watching. If you liked the video, be sure to hit that like button and leave a comment down below. This is definitely a bit more of an unorthodox style in terms of just kind of, you know, going with it and you coming along for the ride. I think it's a bit more organic in terms of the process that I go through normally off camera. And it's, you know, generally something where if you can get good at troubleshooting, especially things like this, reading what it's telling you and being able to research and find the answers that you need in order to be able to accomplish what you want, you know, the world's really your oyster in terms of Linux operating systems especially, but really all operating systems and IT type of work. So if you like the video, be sure to hit that like button and leave a comment down below. And if you think somebody would like this video or the content that I produce, be sure to share it with them. I would definitely appreciate it, and I hope that they would appreciate it too. And if you haven't subscribed, please subscribe. And then hit that notification bell. That way you know the next time we're getting extended. So until then, take care.